Welcome to Techie Wise. In today's session, we will be dealing with the Euclidean algorithm to find GCD of two values. So, if A and B are very large, then it will be difficult for us to go for the factorization method. So, we will be going for this Euclid's algorithm. We will be using this Euclidean algorithm or Euclid's algorithm. Here, we will be using a table with the fields A, B, and R, which is nothing but the reminder. Here, the prerequisite is we will consider the value of A as greater than B. So let us start with an example, GCD of 18 and 12. So here A will be 18 and B will be 12. So what is 18 divided by 12? A divided by B, reminder. So 18 divided by 12. So the remainder is 6. We are not bothered about the quotient. In the next step, B will become A and R will become B. So 12 and 6. So what is the remainder? So 12 divided by 6, the remainder is 0. So the last non-zero remainder is the GCD. Last non-zero remainder is GCD. So here in this case, the last non-zero remainder is 6. So GCD of 18. So of course, here in this case, we can directly find it out. But if A and B are larger, then it will be difficult. So we can see one more example. GCD of 97 and 20. So here A, B, R. So here A is 97 and B is 20. So what is 97 divided by 20? The quotient is 17, right? So now in the subsequent step, so 20 becomes A and 17 becomes B. So 20 divided by 17, the remainder is 3. Now we will stop when the remainder becomes 0. 3. So 17 divided by 3, the remainder is 2. 3, 2. 3 divided by 2, the remainder is 1. 2, 1, the remainder is 0. Right? So here we will stop with this. So GCD of 97 and 20 is 1. Okay. So what is GCD of 750 and 900? GCD of 750 and 900. What we will do, we will take the larger value as A. So A is 900, B is 750 and then the remainder. So what is the remainder here? 150. So now in the second step, 750 divided by 120, which is equivalent to 0. So GCD of 750 and 900 is 150, the last non-zero remainder. So what is GCD of 11 and 10? Please do try it out. Yeah. So GCD of 11 and 10 is equivalent to 1. So here we have to discuss one more property. If GCD of A and B is equivalent to 1, then A and B are called as relatively prime. So if GCD of A and B is equivalent to 1, then A and B are relatively prime. It is not that they are prime, they are relatively prime. Right? So now we can have a look into multiplicative inverse. So here we are going to deal with the extended Euclidean algorithm. So Euclidean algorithm we discussed for finding the GCD. Extended Euclidean algorithm we will be used to find the multiplicative inverse. So before proceeding with the algorithm, we need to have an idea on what is multiplicative inverse, modular multiplicative inverse. Okay. So A mod n. So what is the multiplicative inverse of A mod n? It will be A inverse. What is that A inverse? A multiplied by something will be congruent to 1 mod n. This something is called as the A inverse. A multiplied by something will be congruent to 1 mod n. We will get 1 mod n. So that is multiplicative inverse. Okay. So now we can find, we can proceed with an example for dealing with the extended Euclidean algorithm. Our task is to find the multiplicative inverse of 550 mod 1759. Yeah, of course, in order to find this A inverse, we can go for trial and error strategy, but it will take time. So, if the values are very larger, if A inverse is larger, then in that case, it will be difficult for us. Then in that case, we will be going for the extended Euclidean algorithm. Again, we are going for a tabular approach. So here our task is to find 550 mod 1759. So I am going to construct Q. The table is going to have all these parameters N, B, R, X1, Y1 and X. So what is N, B, R, X1, Y1, X? So Q is nothing but the quotient part, and R is the remainder part. And what is N and what is B? So here the task is to find the multiplicative inverse of B mod N. So here we won't bother about whether N is larger or B is larger. So we will go for directly applying the values B mod N. If I want to find B mod N, then I will be proceeding with this table. So here what is N? N is 1759. What is B? 550. So here we will have some standard values. So for the initial iteration, x1 is equal to 0 and y1 is equal to 1. Yeah, 1759550. So what is the quotient? 1759 divided by 550. So the quotient is, if you divide, we will get the quotient as 3 and the remainder is 109. Quotient is 109. Now we have to find one more parameter, that is x. So here we will use an equation. X is equivalent to x1 minus y1 multiplied by q. So what is x1 here? 0 minus y1 is 1 multiplied by q, which is 3. So this is minus 3. In the subsequent step, b will become n and r will become b, and similarly y1 will become x1 and x will become y1. So here this is 550, 109 and this is minus 3. Sorry. This is 1 and minus 3. Now what is 550 divided by 109? So quotient is 5 and remainder is also 5. Now we can compute x. So this is x1 minus, that is 1 minus y1, which is minus 3 multiplied by q, that is 5. So this is 1 minus 15. So this is 1. So this is 1 minus 15, which is equivalent to 16. Alright. So we are going to repeat the process until r gets 0. So this is 109 and this is 5 and this is minus 3 and this is 16. So 109 divided by 5, the quotient is 19 and remainder is 4. And here in this case, this is minus 3, that is x1 minus y1, 16 multiplied by 19. So if you compute, you will get it as minus 339. So now again, next iteration. So this is 5, this is 4, this is 16, this is minus 339, and 5 divided by 4 is 1 and 1. And here this is 16 minus of minus 339 multiplied by 1. You will get it as 355. So now this is 114. 1 and this is minus 339 and this is 355. So what is the quotient? Quotient is 4 and remainder is 0. So here we will stop the iteration. We will not proceed further. So here we will stop once r is equivalent to 0. So y1 will be, so once we stop, we will have a y1 value, right? So that y1 will be the multiplicative inverse. So we can even proceed verifying it. 550 multiplied, what we want? 550 mod 1759. Multiplicative inverse. What is multiplicative inverse? We discussed 550 multiplied by something should be congruent to 1 mod 1759, right? So this something we have identified as 355. So we have to verify it. So we can try verifying it. So 550 multiplied by 355. You will get it as 195250. So here you can try it out. 5250 divided by 1759. You will get 111.000 something. So now 111 multiplied by 1759. You will get the resultant as 195249. So here you can see the difference is 1. So 550 multiplied by 355 is congruent to 1 mod 1759. Thank you.